Hello students, in this video we will take another example on centrifugal pump. The example reads like this. A centrifugal pump is to discharge 0.118 meter cube per second at a speed of 1450 rpm against a head of 25 meter. The impeller diameter is 250 mm. Its width at the outlet is 50 mm. And manometric efficiency is 75%. Determine the Wane angle at the outer periphery of the impeller. So this is the example. So what is given in the example? Firstly we will state that the first line says the pump is discharging 0.118 meter cube per second. So discharge, which is given by Q, is given as 0.118 meter cube per second. And the pump is running at a speed of 1450 rpm. So capital N is also given, which is 1450 rpm. And also the head on the centrifugal pump, head means it is a manometric head obviously. So manometric head is 25 meter. The impeller diameter is 250 mm. So the diameter of the impeller means its external diameter, which is represented by D2. It is 250 mm, which is equal to 0.25 meter. Now the width of the outlet is 50 mm. So width of the outlet is represented by B2. Width is represented by B, as it is of the outlet, it is represented by suffix 2. So B2 is 50 mm, which is in meter, is equal to 0.05 meter. The manometric efficiency is also given, which is equal to 75%. So efficiency eta manometric is equal to 75%, which is equal to 0.75. Determine the Wane angle. So what we need to find out? The Wane angle at the outer periphery of the impeller. So Wane angle at the outer periphery is phi. So we need to find out this phi. So in this velocity triangles we need to find out this phi. So this phi can be found out by using trigonometries like this tan phi. If we take tan phi, what will be the equation? It will be its opposite side, means safety is Vf2 divided by its adjacent side, which is equal to that much distance, which is equal to this U2 minus Vw2. So using this equation we can find out the value of the tan phi. So firstly reverse engineer this, like if we know the value of Vf2, if we know the value of U2, or if we know the value of Vw2 by whatever the figures given into this problem. So if we need to find out this tan phi, we firstly need to find out this Vf2, U2 and Vw2. So how to find this U2? We know that U2 we can find out. U2 is the tangential velocity. Tangential velocity at the outlet, it can be found out by pi d2n by 60. We know the value of d2, we know value of capital N. So we can find out this U2 as 18.98 meter per second. So into this tan phi equation we have found out this value of this U2. Now we need to know these values Vf2 and Vw2. If we find out these two values, then we can solve this equation. So firstly, what is this Vf2? This Vf2 is the velocity of flow at the outlet. So we have given in the example capital Q, which is the discharge through this impeller at the outlet. So discharge at the outlet can also be written as Q is equal to pi d2v2 multiplied by Vf2. In this equation there is Vf2 and the other values like Q, d2 and b2 are already known, Hence we can easily find out the value of Vf2, which is equal to Q divided by pi d2 b2. So if we replace all these values into this expression and solve it, we will get the value of Vf2 as 3.0 meter per second. So another unknown is get find. So we know now Vf2 and this U2. Now we need to find this Vw2. Vw2 is the wall velocity at the outlet. So how to find this wall velocity? There is manometric efficiency is given into the problem. So the formula of manometric efficiency is eta manometric is equal to GHM, which is the manometric head, divided by Vw2 U2. So in this expression we know value of G, we know value of the HM, we know value of U2, we know the manometric efficiency, so we can easily find out this value of Vw2. So if we solve this for Vw2, we will get its value as 17.23. 17.23. It is obviously meter per second as it is the velocity. So now we know the all three values required to solve this final equation. Tan phi is equal to Vf2 divided by U2 minus Vw2. So we have found out the value of Vf2 as 3, value of U2 as 18.98 and Vw2 as 17.23. So we will get the expression tan phi is equal to 1.7143. If we take inverse of this tan phi, then we will get the value of phi as 59.74 degrees, or it can also be represented as 59 degree 44 minute. So by this way we can solve the equation. So we need to understand what is asked into the problem and then reverse engineer it so that step by step we can find out the solution. Now let's take another example. A centrifugal pump delivers water against a net head of 14.5 meters and a design speed of 1000 rpm. The vanes are curved back to an angle of 30 degree with the periphery. The impeller diameter is 300 mm. The outlet width is 50 mm. Determine the discharge of the pump if the manometric efficiency is 95%. So this is not much different than the previous example. The net head given here is 14.5 meters. So net head on the pump is represented by HM, which is equal to manometric head. It is 14.5 meter. Speed of the pump, capital N, is 1000 rpm. The vane angle at the outlet, as it is given as the vanes are curved back to an angle of 30 degree. So this is the angle of the relative velocity with the direction of the vanes. So it is 30 degree. So value of the phi is 30 degree. The impeller diameter is given as 300 mm. So diameter of the impeller is always the outside diameter, which is equal to D2 is equal to 300 mm, which is equal to 0.30 in meter. The outlet width is 50 mm. Obviously it is the value of B2, means the width at the outlet, which is 50 mm is equal to 0.05 meter. So we need to find out the discharge of the pump if the manometric efficiency is 95%. So discharge through this pump is Q. So we need to find out the value for Q. If the manometric efficiency, eta manometric, is 95%, which is equal to 0.95. So what is this Q? We know the formula for Q. Q is equal to pi d2b2 multiplied by Vf2. So if we need to find out the discharge, we should know the value of this d2, this b2 and this Vf2. Value of d2 is already given, value of b2 is already given, so only we need to find out this value of Vf2. So how to find this value of Vf2? So we know that the formula tan phi is equal to Vf2 divided by u2 minus Vw2 from the outlet velocity triangles. We have seen this formula in the last example also. So in this example, if we need to find this Vf2, then we should know the value of tan phi. In this case, the value of phi is given, so we can find out this tan phi. u2 as the diameter at the outlet and rpm are also given, hence we can find out the value of u2 easily. So we need to find out this Vw2. So if you find out Vw2, then we can find out this Vf2. Now how to find this Vw2? We know that the manometric efficiency is 0.95% in this case, and its formula is given as G multiplied by Hm divided by Vw to u2. Here manometric efficiency is known, head is also known, u2 is also known, so we can easily find this Vw2. So by using this Vw2 value we can find out Vf2, and using this Vf2 we can find out the discharge. So first thing we need to find out is the u2, as it is common in all the equations. u2 is the pi d2 multiplied by n divided by 60. So its value after solving will come as 15.7 meter per second. Now using this manometric efficiency formula, here manometric efficiency is 0.95, head is 14.5, u2 we have found out at 15.7, value of G is 9.81. So we can find out the value of Vw2, which is equal to 9.54 meter per second. Now using the same outlet velocity triangle, the expression for tan phi is Vf2 divided by u2 minus Vw2. Here tan phi is tan 30, Vf2 we need to find out, u2 we have found out above, Vw2 we have found out 9.54. So using this we can find out the value of Vf2 as 3.556 meter per second. So as we know now the value of Vf2, we can use the formula for discharge. Q is equal to pi d2b2 multiplied by Vf2. If you put all these value into this equation, we will get the discharge through this centrifugal pump as 0.1657 meter cube per second. Thank you.